Welcome to Unprofessional Engineering. My name is James.
You got Luke.
Luke, we're joined today by Sinmin, VP of Strategy and Partnerships at ANSYS. Thank you for joining us.
Thank you, James. Thanks for having me here.
Yeah, I'm really excited about this, and just throwing this out there, talking to two, we'll say in another lifetime, simulation guys, so pretty excited about this.
Excellent.
So obviously ANSYS is headquartered close to our hometown of Pittsburgh, Pennsylvania, in beautiful Canonsburg. So one of the great things that I've noticed is that ANSYS really gives back to the community, and especially the education community. Carnegie Mellon University just got ANSYS Hall, I believe?
Yeah, we just have an opening ceremony about 2 weeks ago.
Yeah, that's exciting. And then, of course, there's the Swanson schools, which are, tied to ANSYS in some ways at Cornell and Pitt.
That's correct.
That's exciting. So why does ANSYS invest so much in education?
Well, at ANSYS, one of the things that we have been continuing to focus on is to lower the barrier to adoption of simulation.
Mm-hmm.
And there's a saying, capture the mind and soul of the students, capture them for life. We want students to learn simulation when they're at school, because traditionally simulation used to be used by high-end PhD analysts. But we want simulation to be used not just by the PhD guys, but also by undergraduate. And now we are even pushing it into high school through the STEM program.
That's great. We have a lot of STEM connections through our podcast, actually. A lot of teachers that have reached out to us and different things like that. It's amazing that simulation is actually getting brought to that level. And just considering when I was in college, I had one class about hand calculating matrices to do FEA by hand, and then actually using ANSYS Classic to do some very simple analyses. And now people in high school are doing that.
Yeah.
That's amazing to me.
Yeah, absolutely.
Wonderful.
So I like the idea that a kid can be doing better simulations than James or I could.
I don't want to think about that, thank you.
So where are we at now? We going over to our questions?
Yeah, so not so long ago, Autodesk and ANSYS teamed up in the automotive space. So that's not necessarily what we want to talk about, but I had a few questions about it. So apparently there's a connection between VRED and SPEOS. Did I say that right?
That's correct.
SPEOS, for those of you listening.
Yeah.
Could you tell us a bit about that?
Yeah, so let's take a step back, why this is so exciting.
Mm-hmm.
Traditionally, car company use clay model to do craftsmanship validation. They put in a white room to study how the character line, the body get formed. But with technology, with computer, now we can actually do the visualizations on the computer virtually, and you'll be able to simulate how the car looks like in different lighting conditions, in different material, different usage. But through this partnership with Autodesk, what ANSYS is bringing is real-time physics simulation. And you might ask, why is this so important? Well, it's important as car companies are increasingly rely on simulations to understand things that they cannot do it on the visualization world.
Okay.
As an example, regulations, federal regulatory requirements now require car company to be able to launch a car that have a tail light that be able to emit the warning signal.
Wow.
And any conditions, whether it's snowing, raining, or thunderstorm, or hail.
So all of the Pittsburgh conditions that we're used to.
So basically,
pretty much all the Pittsburgh conditions.
Yeah.
The 300 days of the year with overcast sky, dark, raining, and that's very important. And what ANSYS can do is we can actually simulate those changes that caused by the environment, the weather, and be able to overlay those physics simulation on top of Autodesk VRED world-class visualization to make it hyper-realistic, so that engineers can make decisions much sooner than they used to do.
Okay.
So we're huge fans of autonomous vehicles. I'm sure you listen to our podcast all the time, and you're a fan of the show. Are there any kind of interesting stories or anecdotes that you could share about the partnership that's happening there?
Oh, so again, going back to VRED, right? VRED world-class in terms of virtual reality, in terms of visualization. And one of the things that we are trying to do to help automotive companies to accelerate the deployment of autonomous vehicle, level 4, level 5, is to accelerate the testing. Today it takes about 8 billion miles to get a vehicle ready.
Did you say B with a billion?
B with a billion.
Wow.
And to put it in context, it's about 200 years of driving, right, to accumulate that many miles. So by combining physics, right, because ultimately, autonomous vehicle is not a disruption on the car, it's disruption on the driver.
Right.
How do you help the car to learn how to drive just like we learn how to drive? And to do that, you need to have good visualization of what the environment looks like and good physics to be able to help the car learn to make good decisions. So by combining high fidelity physics and world-class visualization of Autodesk, we believe that we can accelerate the learning of the autonomous vehicle and as a result be able to launch the next level of autonomous vehicle that with the kind of reliability that the car company expect.
I really want to keep talking about that because it's so cool.
I
We
love
have so many
autonomous
cool connections from Pittsburgh that are involved with that.
It's funny that you say Pittsburgh, right? Pittsburgh was deemed the city of the future by CNN. Why? Because if you go to downtown Pittsburgh, you're going to see a lot of cars with a lidar spinning on top of the roof. Uber, Argo AI, and CMU, of course, have tons and tons of, in fact, the father of autonomous vehicle, Red Whitaker, who won the first DARPA challenge, CMU.
Yeah.
The godfather of autonomous vehicle, Raj Kumar, CMU.
We might have to put that in our lightning round of Q&A questions or something like that. That's great.
Impressive.
That's a good fun fact.
So enough of the VRED and the SPIO stuff here. You're talking to two guys who love traditional FEA and CFD. So what can you tell us about the huge announcement that just went on about the latest partnership between Autodesk and ANSYS?
Yeah, what's exciting about this is what we're trying to do, is number one, right? I believe a good partnership starts with alignment of vision. Autodesk vision is about design and make. How do you make more, better with less? Our vision is pervasive simulation, embedding simulation throughout the whole product lifecycle. It's about helping customers to make better decisions faster. So this partnership is about crushing the barrier between the design, the engineering world, with the analyst world. Today, a lot of work that is done by the designer or the engineer in the fusion environment get lost, does not persist when it gets pushed into the ANSYS simulation tool. Through this partnership, now we're creating a seamless workflow where all the simulation model or every CAD model, all the property that you do in Fusion get moved to ANSYS environment without losing anything. So all the property persists, which is reducing a lot of hassle, duplication of work, and waste of time between the designer and the analyst.
So when we think about this partnership, exceptionally cool partnership, like you said, these mission statements of the two different organizations they dovetail, really well together. This idea that we can go, from Inventor to Fusion, we can run a generative design study, take that information out to ANSYS in a single click. So what kind of examples, like what use case would this maybe happen in?
Yeah. So a lot of customers are actually very interested in generative. I do believe that generative is the future for design. Students or engineers, they don't necessarily have to use the tool and let the computer do a lot of the number crunching behind the scene.
Okay.
But at the same time, creativity still needs a human in the loop.
Yeah.
So by combining generative design that are by and large machine driven and then marrying it with simulation in the validation phase, you're putting human in the loop so that you can actually embrace the machine, but layering in the creativity of human that can provide, making the solution much, much better than just blindly taking whatever the solution come out from the computer.
So I guess I want more details on the workflow. And I'm talking to a few folks later this week as well about this process. Yeah. Now, if I set up a model in Fusion, let's say, and I go through, I'm setting up all of the properties, I do my generative analysis on it, we're all happy with the way it looks. Yeah. I click my button, I send it over to ANSYS. Do I have to reapply those material properties and everything else? Of course, the boundary conditions and those things. But what if I'm just doing like A36 steel, because that's what generative parts are made out of. But let's just say as an example.
Yeah. So first of all, generative design provide inspiration for the designer what the part should look like. Then the engine will pick 2 or 3 design that they like. They bring it down to Fusion and do some refinement with Fusion simulation or Inventor simulation. But then all the properties that you just mentioned that are defined in the Fusion environment, boundary condition, the loading condition, the mesh property, the material properties, the size of the elements, those will persist once you get pushed to ANSYS environment. So the analysts, the high-end analysts can take the model, the simulation model that come from Fusion, and take it from there without having to recreate and rebuild all the simulation property and do the final validation. And this is what ANSYS brings to the table. Higher fidelity physics to do the validation sign off before the product gets manufactured.
So when we think about simulation geeks like James and I, if you could talk to us a bit about solver options, different meshing options, the capabilities that ANSYS Mechanical has that you might want to highlight. So what are some of those?
Yeah. So on the traditional ANSYS Mechanical that is built on Workbench, we have one of the most intuitive user environment where engineers can pretty much leverage a lot of the templatized meshing capability that are tuned for the type of physics or type of problem that they're trying to simulate. But as we move forward to the future, computing power is getting faster. We are also re-engineering the way meshes are done to take advantage of processors such as GPU. Mm-hmm. So at the Autodesk University 2019, we actually have a booth here that talk about Discovery Life that is basically would not require engineering to do any meshing because the meshing will be done behind the scene. And they will be able to generate real-time simulation, real-time results, at the speed of thoughts.
It's great thinking of going from using ANSYS Classic, where I was sitting there hand meshing things to make sure that I don't have any tets so that I can then extrude the mesh to make everything perfect. And now you're like, well, in the background, it's just going to be doing this for you.
It almost makes me mad that I learned and used the software 20 years ago. It's so different.
Well, you don't have to feel bad. When I did simulation, I had to do it on a punch card.
I wasn't going to say that.
I'm going to date myself, but I'm telling you, it's exciting. We're living in an exponential world. The world is doubling in price performance capacity every 12 to 18 months. And who knows what the future holds. I can guarantee you, my kids will probably not even know what simulation is, but they will be getting the insights from simulation to make good decisions without them even knowing it.
Yeah.
So we only have a couple more questions left here, and I want to just dig in a little bit more because I just miss my simulation days. So we talked about how you can bring the Fusion simulation things over and the materials and all of this stuff. Now, I'm kind of throwing this out as a PSA for all of our Fusion folks out there because I know they're going to get all worried. This doesn't mean that simulation in Fusion goes away. It doesn't mean that that's not something that you're capable of doing or that we're not committed to. But it really gives us that opportunity to work with people that are already committed to working with ANSYS, or maybe also have to do some advanced analyses with different materials, different material models, different solvers, different meshing options. Could you speak to some of the different material models or other geeky stuff I love?
Absolutely. First and foremost, this is not about displacing what Fusion brings to the table. This is about expanding the usage of simulation and also the availability of the different physical models. The world is amazing. The natural phenomena is limitless, and what we can simulate is infinite. So by combining forces between ANSYS and Fusion, what we are offering to the user is a broader, deeper physical models that they can use to study things that they might not be able to do it currently in the Fusion environment. Not that there's anything wrong with it, because that Fusion was built for a specific purpose, and that's for design, for understanding design, engineering, and how to make products better with less resources and faster. And ANSYS simulation is about validation, it's about sign-off, it's about taking it to the nth degree level so that the companies have confidence before they launch the product.
All right, so we're running out of time here, but before we go, let's talk a little bit about the future. So I've heard rumblings, because that happens around Autodesk. Sometimes you hear rumblings that our partnership might actually continue to grow with what we're working on, to the point that maybe we'd even be able to take stress results from ANSYS Mechanical, bring those back into Fusion 360 after we run these advanced analyses, and then do further design work on that. Is there anything about that you could share with us?
What I would share is that I think both ANSYS and Autodesk, going back to the alignment with vision, right? We are about how do we make design and make a reality? How do we make pervasive simulation a reality? And the only way to do it, right? And this is going back to customers. They have problems that no vendor by themselves can solve. So by combining by combining a technology, and more importantly, by embracing open ecosystems, bringing the best of technology to unlock those solutions that no vendor can solve by themselves. I think that's where the future is heading, not just necessarily between Autodesk and ANSYS. It's really about how do we create an open collaboration innovation model for all vendors to work together, because ultimately it's about solving the customer problems. And if we can unlock value by working together, more power to the customers.
Yeah, I like the idea of working together, because I'll be honest with you, whenever I think of the history of Autodesk and ANSYS and all these other simulation and CAD companies, the thought of a partnership like we have right now, even just 5 years ago, is something I'm not sure I would have thought would be happening. And now we got multiple partnerships going on, and I think it's probably a good sign for future relationships.
Yeah, it's a good sign for the future relationship, a good sign for customer, because as McKinsey say, right, the Industry 4.0 offer a potential value to be unlocked in the tune of 11 to 17 trillion with a T. And it's not a zero-sum game.
Yeah.
That's the way the world is moving towards. It's not a zero-sum game. The pie is big enough for everybody. The most important thing is let's figure out how to work together to solve problems for customers, so we can unlock those value, those 11 to 17 trillion dollars of value that will make the world a better place together.
All right.
I think that's a great way to end. Make the world a better place
exactly.
together.
I'm inspired. And we're told that you have other things to be doing today. So we're going to go ahead and let you go. But again, Sin-Min, thank you very much for joining us today.
Thank you very much for having me, and I wish you all the best for the rest of the week.
Excellent. Thank you.
Have a good day.